Hey, what's going on, guys? So today we're going to be looking at passage number 3, and this is from the SAT number 17, or this is the April 2019 QAS test. And what we're going to do is just go through the passage really quickly, just point out some of the key details, give you a little bit of a breakdown of how the passage works, and then we'll go from there into the questions. So first thing we can look at is the title of this passage, which is How Rare Woodland Plants Use Cryptic Coloration to Hide from Predators. Doesn't really tell us too much right off the bat unless we know what cryptic coloration is, which is basically camouflage. And so this is saying that plants are using camouflage to hide from predators. Okay, gives us a little bit of insight. This first paragraph here basically says it's well known that many animal species use camouflage to hide from predators, right? It explains why that's a good idea. And then it ends with this, but who ever heard of a plant doing the same thing? So far, this is a pretty typical structure for an SAT science passage where we're introduced to sort of like a general phenomenon. In this case, it's camouflage and sort of the evolutionary logic of camouflage. And then here, basically saying whoever knew that plants do the same thing. Then we get down here in plants, the use of coloration or pigmentation to attract pollinators is well studied. However, using pigmentation to escape predation or as camouflage has received little attention. And then Matthew Klooster is a guy who wants to investigate this specifically in this one plant. He wants to know if basically its coloration might serve a similar purpose to the stripes of a tiger or the gray coloration of a moth. In other words, is this plant using camouflage? So that's this second sentence or second paragraph here. Again, pretty typical of an SAT science passage where once we go through the general phenomenon, then we're introduced to the more specific target question, and then we're introduced to the researcher or the scientist who investigated this. So now we know we're looking at a specific plant to see if it has camouflage. So here is Klooster explaining some things about the plant species, right? And then down here, basically this is explaining the methodology of the study that he used. He used a large population of the species. He basically took away the bracts, which are basically these little dried, almost like leaf-like things that cover the entire plant. Then he just goes through it, keeps explaining it. Furthermore, blah, blah, blah. So here's the conclusions. They experimentally demonstrated that this camouflage actually worked to hide the plant from its predators and increased its fitness. That's also the conclusion, I think, actually starts here. Yeah, I think maybe it is down here. So what they do show is that in this plant, the plant is actually using camouflage, and this camouflage is helping to it to avoid predators and to increase its fitness, etc. And then here's a quote from him. It's long been shown that animals use cryptic coloration or camouflage to visually match a component of their natural environment, which facilitates predator avoidance. In other words, basically, we know that animals use camouflage to avoid getting eaten. Now we have experimentally demonstrated that plants use the same strategy to avoid their herbivores. So this is just him basically giving a quote about what he discovered, which is that, hey, this plant uses camouflage. Then down here, this explains that drying its bracts, right, using these dried outer leaves or whatever, early to hide its reproductive parts is a good strategy when the stems are exposed to predators for long periods of time, etc., etc. Somewhat paradoxically, however, Monotropsis odorata actually relies on animals. So they're saying it's somewhat of a paradox because this plant species uses camouflage to avoid predators. However, it needs to attract pollinators as well. So how does it do it? And authors hypothesize that the flowers emit highly fragrant odors that attract pollinators, etc., etc. So that's sort of the basic outline of the passage. Again, fairly typical of science passages. We start with the phenomenon of camouflage in general. We ask about whether plants have camouflage. Then we're introduced to a researcher who specifically studied this, basically a quote giving it some background information about the species. Then he goes and talks, we get the study, basically what they did in the study. We get the conclusion in two parts, and basically the conclusion is that these plants do use camouflage to avoid predators. And then we get this last one here, which explains, again, sort of the logic of it, but introduces this paradox that at the same time that they're trying to avoid predators, they need to attract pollinators, and answers the question, or at least gives a plausible hypothesis for how this works. So that's basically this passage here, and then from now on we'll go and look at the questions.